on a weekend. So I'm Subhashish. I'm the senior technical, PM on the Azure OpenAI service. So I'm part of the customer experience engineering team, which is part of the Azure AI platform team at Microsoft, actually. Uh, Quickly moving on. So we will cover, today some basic, generative AI, like what it's meant by that, some concepts you need to know. We'll go into depth a little bit, into transformers, foundation models. These are like fundamentals. We'll look at, certain de-jargonization, what we call, some complex things made easy. Gen AI, some, build, Microsoft Build is a big Microsoft developer event. So top, a couple of announcements related to AI from that event. We'll definitely take a look at Gen AI, use cases. And then in the demos, I'll show you some OpenAI Python SDK using Visual Studio, some programs which you can run on your own. And, and also there's something called a semantic kernel, which is basically an open source, kernel developed by Microsoft. That's in C Sharp. I'll quickly show and then hand it over for the quiz in the Q&A, right? Okay, so thanks, folks. Um, so let's understand. So the essence of artificial intelligence, that the first, let's call it the founding fathers had thought of or dreamt of, was a very simple vision. Can the computers someday understand us instead of us making all the efforts that we do currently, trying to understand them? I mean, that's the core essence. Probably someday. So this still remains the underlying force of the research, the mathematics, the effort that goes on into building complex machine learning algorithms, complex neural networks, and so on, leading up to what is today referred to as the generative AI. So this is the driving vision of generative AI today as it stands. And just to set the context here, the key takeaway here is that generative AI is not something entirely new, but rather builds on decades of research done by researchers, mathematicians, statisticians early, from let's say 1900s till date. So technically, history of AI kind of dates back to 50s, right? So you had the expression first used by John McCarthy, then pushed forward by folks like Alan Turing. Then 1982 onwards, we had a period of RNNs. If folks have worked on it, recurrent neural networks. It was introduced by someone called John Hopfield, right? Which eventually, 1980s, we had Jan LeCun with the entire concept of convolutional neural networks. I have neurons passing information context via different layers of a neural network, which is referred to as CNNs. Now, CNNs work pretty well for a lot of machine learning use cases, and I'm sure many of you on the call would have tinkered a little bit with it. But eventually, it ran into certain issues, not being able to store and process what we call contextual information between the layers. In complex, natural language processing tasks specifically, complex speech to text, text to speech, translation, stuff like that. So fast forward modern deep learning in 2012 with AlexNet, and then we had a major breakthrough for language model, which is very important. We're going to touch upon it today as well. Is a transformer research paper called "Attention Is All You Need." 2017 Vaswani et al. That's a paper you must take a look on, which kind of describes in detail something called a transformer model architecture. This research paper laid the foundation of what is the generative AI world today. So in summary, if you are hearing the term Gen AI for the very first time, the only thing that you really need to remember is that Gen AI kind of allows you to create new and original content by learning patterns in data. It could be written, visual, auditory content, right? And this studying of these patterns in data, it's usually done through the use of very complex algorithms and methods, inspired by the human brain. And we're gonna touch upon a few of these, today as we proceed forward. So let's understand the concept of tokens, before we understand the role it plays in large language models, LLMs, and specifically in transformers, which forms the base of, generative AI research today, because this is the fundamental. So, and you're gonna hear about this all the time if you, plan working with, generative AI, either as a user or as a developer or as an AI engineer or as an architect or maybe as a, TPM someday, like myself, right? So what is exactly a token? Token, simply put, is the smallest unit of analysis. In other words, a token is a minimal word part. Example in OpenAI, right? Large language models. For English, one token is equivalent to give and take 4 characters, which is approximately 0.75 word. That's in English. So essentially, GPT models predict tokens based on the hundreds of billions of tokens in its training set. Now, this is very important. So your obvious next question would be, okay, I understand what a token is, theoretically. You're mentioning it's like a 0.75 word in English language, but how is it, generated by a, GPT model, a generative pre-trained transformer model like, OpenAI, GPT LLM. So what an OpenAI large language model does is during its inferencing process for producing a token, it essentially goes through these 9 layers that you see on the screen. And these are pretty important to understand because this is the crux of what the tokenization process in generative AI talks about. So the first process itself is tokenization. So here, what the model pipeline essentially does is it converts. You provide an input sequence. It basically converts the input sequence. Let's say a sentence. Let's say Subhashish works at Microsoft. I take this sentence and then it convert it into tokens using an algorithm. So that algorithm is called a tokenizer. So there are different tokenizers available in the market. You can choose from what you need. The 2017 paper, the transformer model that you'll see in the next slide, basically Google used something like a byte pair encoding. So if you are an algorithm developer or a architect, you're gonna face BP quite a bit in your career. So byte pair encoding is a type of tokenization as a tokenizer it's used. Model input basically at this step, the pipeline passes the tokenized sequence into a pre-trained model. Model this basically represents the specific LLM model that you want to use, a large language model. For example, in my demos, I'm going to use GPT-3.5 Turbo module. Correct. So basically, it processes the input through its various layers. And we're going to see in the next slide in Transformer, essentially, of two important layers, a multi-head attention and a feed-forward network. Output generation is basically, model produces a raw output logit given the input sequence. Sampler basically means it converts these output logits into probabilities. Now, this is a very important step because I said the output logits are converted into what? Probabilities. And the next token selection basically selects the next token based on the best probabilities of the earlier step, the sampler. So as you see from basically input sequence converted into tokens, basically, I've ended up at a sampler. The sampler is then studying the probabilities. And then the next token selection and then addition, happens. And basically, generation completion is the step where once completed, you have the maximum token limit either has been reached. And final step is when the text reconstruction happens. So at this step, the LLM, basically the tokenizer converts the final sequence of tokens back into what we call a string of text and then gives it to you. Now, this is very important because essentially what I explain in these 9 steps is if I put it in a very simple format, an LLM, what basically is doing is a large language model essentially doing is taking an entire input sequence and then producing a single or one token, if you notice. So that token is then added back to the sequence and the model starts all over again to produce another token. And this iteration kind of, continues. So if you see input to model the output and then again goes back to the input, right? So we can sum up the steps in the entire process as input, the large language model processes the input, the final and output, when the next token is added to the end of the input, the maximum number of tokens reached is, kind of requested is reached. So this process is basically called a one token output revolution. In other words, very simply put, in English, if I may say, an LLM, the large language model, is essentially at its simplest level, a token by token generator. And to summarize this mathematically in white papers, you will see this is represented as basically T as a function of N, where T is one token and F is basically the model and the output controller that infers the next token. And N then basically, I'm representing the initial sequence of token plus each new text token that is added to it. So in simple terms, like mathematically, what I explained in this English in the extreme left, the 9 stages to the extreme right, an LLM basically processes N and produces T. It's like as simple as that. So now, we'll not definitely go into depth or into brevity of time today, but at a very high level, you need to understand what a transformer is. I know it's a fundamental for generative AI research, and if again, if you ever want to build your career, working on, generative AI, this will be the basis of all of your work, right? Very simply put, a transformer model is technically a sequence to sequence model, we call it. So there are like 3 variants to this model, and these are very important, for a developer or an architect or a program manager or an SDE to kind of master, because this decides the type of use case you're going to work on, what are the different variants you're going to specialize in. So what are the 3 different variants of the transformer model? And it depends basically, how it uses something called the multi-head attention. We're going to talk about it right now. So the original 2017, you had the encoder decoder unit, the variant. Then you have the encoder only, which was popularized by Google BERT actually. But the problem is it's very strongly regularized. That means it doesn't have much freedom, so it's not useful anymore. And finally, you have the decoder only block, which you see with a green tick, which has the least structure. That means it has least regularization. Heavily used. Majority of your LLMs in the market right now today are decoder only, you will find, and it's heavily popularized by ChatGPT, most useful for building industry use cases. So ideally what a transformer does is it takes a sequence as an input, wherein I have an input with elements of words, images. So for example, here I'm basically, tokenizing an encoding scheme with a fixed number of integers. And then basically the dominant paradigm right now is, after tokenization, basically, what I do is I represent each sequence element as a vector, dense vector, we call it, because we eventually need to kind of multiply them. So technically, we arrive at a sequence of vectors, we call it. So all we need to do is basically, model the interaction between the sequence elements. And then eventually at the last step in English, what I explained in the earlier slide is we kind of reach a stage where we do a probabilistic distribution of the most contextually relevant vector. That's how essentially an LLM works. So there is one thing which you need to remember is, an LLM basically has a combination of two things. One is a multi-head attention that models this interaction between the sequence elements. Correct. And very important is a feed-forward network. The feed-forward network essentially, is defined as the dot product attention, basically. So now, very important to understand, and again, at a very high level, is what the encoder decoder does. So here, for example, in this use case, I'm basically converting English into German. So I feed in a English that is good. I want to convert it into German. So eventually, I need a system which should produce, das ist gut. How do you do it? So we first take the input sequence and encode it into a dense vector. Right now, as I explained, the lines are representing the dot product, actually, these, multiplied. So any token can talk to any token, and then the feed forward network is, per token. There's one layer, and we then repeat it n number of times. That's why I see layer one on the screen and layer n multiplied by n number of times, right? And at the end, it generates what we call again a sequence of vectors. So that's one layer, and we repeat it, n times. So each sequence is then an element. So here, for us, it would be each is basically a word. In the decoder block, again, it's identical set. We repeat the same thing. But this has, in addition, a new thing called cross attention. If you see, this is not there in the encoder, but it's there in the decoder block, right? So this is the causal self-attention, which means basically at the time step t, I can only attend to t, but before that, I don't have in the future tokens. So after processing the n number of layers, again, you see here layer n, here also you see layer n, you eventually get an output sequence. Very important question comes up is how does the encoder and the decoder, connect it to each other? It's essentially via the cross attention mechanism. If you see, each of these are connected via the cross attention mechanism. That's a high level overview of what basically an encoder decoder, transformer does. But this is not very common because of very strong regularization. The one which is very common right now is a decoder only. So the decoder only can really generate new stuff. That's audio, video, visuals, images, text, code, all the NLP stuff that's going on right now, highly popularized by ChatGPT. This has an identical architecture like this. This is the decoder only. So personally, again, this is my favorite, everyone's favorite right now. So GPT again uses the decoder only model. So what you have here, the trick is to basically, as you see here, key design features. Two important things are there. The first one is essentially concatenating the input with a target. So ideally it becomes a sequence in and a sequence out model. So you see input and the target are concatenated. That is good. Correct. And going to, Verity again, we'll not go into further, but the most important thing also is then the self-attention also serves in the role of cross-attention. So the self-attention layer, as you see here, has been merged with the cross-attention. The self-attention serves as a role of cross-attention, and basically it takes a sequence bits in via tokenization, multiplies with n number of layers, then causal self-attention is added to it. Then finally, an output sequence is generated. Again, just the key takeaway from this slide is, do not worry about the maths. If you want to kind of go deep in it, you should look at attention is all you need, the paper, right? The takeaway is that transformer variants are here to stay. And, they offer the best solutions in building what we call the foundation models. Now, that brings me to a very important question. I hear this, like, what is a foundation model? Now, advanced large multi-purpose transformer models, they represent, a very big paradigm shift in the, industry. Hence, they are referred to as foundation models. Now, an important point to note here is the foundation models, again, they were not created by the academic world, but by the big tech. So Google pioneered this, invented the transformer model 2017. They built the BERT, Lambda, Palm 2. Then Microsoft came in. They partnered with OpenAI to produce the OpenAI LLMs and now the Chat GPT. So an important question to ask here is a fundamental is why did these large tech companies like Microsoft, OpenAI, Google, Amazons of the world investing in foundation models? So industrialized AI have very two distinct important features, which are right now very important from an industry perspective. And especially if you are kind of looking to enter this industry as a tech person, that you should be aware of that is homogenization and emergence. The entire industry stands on these two features of these foundation models. So what's them? So homogenization basically allows us to use one large language model to perform a wide variety of tasks without repeated retraining. Now, these abilities basically emerge, that's why it's called emergence, through training billion parameter large language models on massive supercomputers, with massive computing power. And the only thing is, the important thing is that these AI models, as you see on the screen, right? The large models started from 100 billion to 200 to 700, 800. Now it's over a trillion parameter, modeled, LLMs. So they're getting larger, as we say, right? And in the immediate future, for reaching 100% AGI, that is artificial general intelligence, would be larger and larger models, which would kind of require equivalently massive scalable compute architecture. So without going into much details, the key takeaway from this slide is that if you're looking to build an LLM from scratch today, you're ideally looking at using tens of trillions of tokens, which are passed through these massive industrialized foundation models for them, get to learn these abilities. Quick recap here is GPT-4 is built on GPT-3. GPT-3 is built on the GPT-2 architecture for all of you on the call to know. But a fully trained GPT-3 transformer is an example of a foundation model. So it can effectively do two things. So if ever you get asked this question, right, I mean, what's the definition of a foundation model? It should be able to perform many tasks which it was not explicitly trained to do. So this comes via the emergence properties and GPT-3, 4, the 4.0, the new one, right? Even the Omni, generative abilities apply to various NLP tasks, text, audio, video, visuals, programming, correct, and advanced NLP capabilities. So these all come via homogenization. So these two properties are very important if you are looking to build, a complex, let's call it foundation models in the future on your own. So before we look at specific models and some demos, right? And important things to basically summarize and explain the correlation between three things. I often come across people whom, they have a little bit of confusion across, a couple of things. These are fundamentals. So any sort of work you want to do with LLMs, you have to deal with these three. So first is the token. What is a token? We covered that in depth, right? It's the smallest unit of analysis. You need to choose a tokenizer depending on the objective of your NLP project. Now, transform models commonly use byte pair encoding BPE, and they also use something called a word piece tokenization. So there are over a dozen type of tokenizer, algos in the market, and you can choose the one which kind of suffices your need. For example, on the slide, you can see you can do a sentence tokenization. This is a sentence, it's one token. This is another one. Word tokenization cuts the input sequence items so to each as a token. So this within the input sequence is basically an item. So this is taken as a word tokenization and tokenized. Regular expression, you got tokenization, you got tree bank tokenization, you got white space, PP, punct, multi-word. There are multiple type of tokenizers in the market. Second, very important is parameter. So parameter is a numerical value that defines the behavior of a model. In the context of large language models, parameters are adjusted during training. you have to remember, and to optimize the model's ability to generate what we call relevant and coherent text. This is very important. For example, a parameter might define the strength of a connection between two neurons in the model's architecture. So what should I tweak for that? The parameters. And very important is also weight. Now, what is weight? Now, they're correlated, but weight has its definition of its own. So weight is basically a type of parameter, but it defines the strength of connections between the neurons across different layers in the basically model. And these are pre-trained usually, and if and when pre-trained, the weights of an LLM determine some form of machine IQ, which eventually, provides the ability to produce new content. So weights are pre-trained parameters. Parameters are the numerical values determining the behavior of the LLM, and token is the fundamental, analysis, which basically, provides a meaning of a language, right? And it comes through via the entire input, which is referred to as the input sequence. Now, weights are of different types. Again, the type really depends on the type of model you're building, right? You've got embedding weights. So it's a semantic meaning of a token. If you want to determine influence of token on each other within a sequence, you want self-attention weights. So where do they come from? This is basically the self-attention layer parameters, correct? So they are pre-trained, hence the weights. A feed-forward network, we spoke about in one of the slides, right? The compute layer's outputs. So these are parameters which are pre-trained with an influence on the machine learning. They're referred to as the feed-forward weights. Then you have different other type of weights, the bias weights, and so on. So without going into too much detail, but you need to know these fundamentals. I have an input sequence, I tokenize it, I have parameters, which are numerical values, I have weights, which are pre-trained. Now, I'm sure everyone on the call knows who these two people are. So you can see the Azure OpenAI LLMs listed on the screen. Very important. Again, these are all updated as of today, but they keep on changing. So you need to really refer to the latest one, which I provided a link for. This link, learn.microsoft, this concepts model gives a complete list of models. Now, this is always live and updated with information for a model ID, both GA and preview information, description, max tokens, training date, and all of these other, details and paraphernalia. At a very high level, you need to know that, GPT-4o, O stands for Omni, is our latest general availability multi-modal model. So what's meant by multi-modal model? Basically, multi-modal model means it's focused on text plus vision plus audio processing capabilities. It has a JSON mode. It allows features like parallel function calling. It has enhanced accuracy, much better responsive, low latency than the other ones. It has what we call parity with the English text and coding task compared to GPT-4 Turbo with vision. Next set of good models, if you don't want to use GPT-4o, is GPT-4 Turbo with vision. GPT-4 Turbo is again a large multimodal model. Again, what's a multimodal model? It's basically accepting text or input, image inputs, and generating text. It's as simple as that. It can solve, again, difficult problems with greater accuracy than any of the OpenAI's previous models, right? Like GPT 3.5 and others. If you're using it, it's better to use Turbo with vision. Again, Turbo is basically with vision, is optimized for chat, works well for traditional completion tasks also. The latest one is 2024-0409. So the ones which, with blue new are the latest one as per this documentation. And then you have the GPT-4 model, right? Which is the predecessor to 4 Turbo. Both the GPT-4 and 4 Turbo, please remember, have a base model name of GPT-4, as you can see, right? And you can distinguish between the GPT-4 and the Turbo, basically depending on what we call the token context length. And we'll talk about that in the next slide. And they can process it. Remember, finally in GPT, we have the GPT 3.5 as well. So 3.5 and that basically, 3.5 Turbo. But before I move on, just wanted to showcase here that please note these GPT-4, 0125, Vision Preview, and 1106. They're all in the preview modes, and recommended is not to use the preview models in production scenarios, hence kind of marked in red. The other ones are all in GA. GPT 3.5, again, my demos today will be all on GPT 3.5. It can basically, 3.5 models can understand and generate natural language or code. Again, the most capable and the cost effective in the GPT 3.5 is the GPT 3.5 Turbo, which has been optimized for chat and works pretty well for, traditional compilation tasks as well. We'll see it today. Then OpenAI also produces, or has, what we call third generation embedding model. These are denoted by the term three here. You see three large, three small. These are basically, denoted by three in the model ID. So embedding models are algorithms trained to what we call encapsulate information into dense representations in a multidimensional space. And technically, these are embedded vectors, right? So data scientists use embedding models basically to, enable ML models to kind of comprehend and then reason with, high dimension data. So then you should use these embedding models. These are pretty common actually if you're building very complex, industry level applications. And DALI model, if you're aware of it, basically generates images from text prompts. And DALI 3 is generally available for use right now. It also has the REST APIs, correct? And both E2 and E3 have client SDKs as well. Whisper is also again very important. Whisper is again an Azure OpenAI model. It can be used for speech to text, what we call STT. So again, this is as of today, but this, sheet keeps on changing. So please refer to the, live documentation for, all the updated info. So those OpenAI models which get onboarded onto the Azure platform are referred to as the Azure OpenAI service models, and they're available to use with their enterprise customers, right? Now, this section I've called basically removing confusions. I kind of tend to meet a lot of people who kind of tend to mix up certain concepts at times. It's good to kind of de-jargonize a lot of generative AI confusion out there. So removing some, basically, models and explaining what these terms mean. So what does things like, if you open up any documentation, right, you will find you have things like model ID, you have things of context length. It's also referred to as context window size, correct? You will have max request tokens, and these terms will come up GPT-3.5 Turbo. It'll be written like this 0613, it will be written like 4096, 4099. And what do these mean, right? So first and foremost, how do you read it correctly? So when you come across a model ID, you should first take down the model ID. So for example, a GPT-3.5 Turbo, right, model, you will find it listed in the GPT-3.5. It's also listed as 0613. So on our Azure documentation. So 0613 basically refers or signifies that it's a snapshot of the main LLM model or the foundation model underneath the Turbo on a specific date. And this has been now made ready. Certain checks have been done across security. It has been then onboarded into Azure as a platform and then available to customers. So it's called GPT-3.5 Turbo with a 0613. It signifies a snapshot of the foundation LLM. Just remember this on a specified cutoff date. It allows for users to maintain a fixed date of the model to query against, ensuring that the returned output is consistent. So if you type a message across and then send it across or do a programming LLM an application built on this, that I'm standardized across a particular, snapshot date. Now, context length. Now, corresponding to this, what you have chosen in the model ID, you will find there's a context length or a context window size. So what does this term mean? Technically refers to the amount of text the model can receive as input when generating or understanding language. So in summary, what happens, this is the size of the LLM's available memory that is preloaded with your question, plus the answer must be generated following that input. The total is referred to as the context length or the context window size. So how do you measure this? This is basically measured by a set number of tokens again. It's a words or part of words, right? And directly influences, this is very important. Why? Because it influences the amount of information a model can leverage in its subsequent token prediction. Therefore, it's very essential in determining a model's ability to make coherent, what we call an contextually relevant responses. Again, very important fundamental question here that often I get to hear from people is, does it mean that any LLM with a larger context length is always better? Again, the answer is really not always. It really depends on your use case. Why? Because in fact, LLMs or LMMs, large multimodal models, right? If you take anyone which has a large context size or a context length or a context window size, right? Eventually it's not always that it's good. It in fact has three drawbacks. It means it will demand more computational power and memory, posing a trade-off between performance and resource efficiency, right? And also it increases the context provided to an LLM as measured by the input token count, directly impacts operational costs. So your cost will also increase. And again, also it will affect your latency, right? So it has to be a balance between the three. And what is max request or tokens? Now, this is If you do an OpenAI API call, you will find the max underscore tokens, parameter. It refers to the area within the context length, which can only be used for generated answers. Basically, for the length of the generated purpose is basically reserved. It also means that the maximum size of the answer I can receive back. So again, it's the maximum number of tokens of that response. So for example, I've given an example. Let's say I'm using an Azure OpenAI model. It's a GPT-3.5 Turbo in my app. In my demos, I'll use this, right? So LLM has a limit of 4096 tokens. And I set, let's say on an API call, max tokens 1000. What does this mean? It means technically my generated response would be within 1000 tokens. And 4096, this is my upper window size minus the max tokens, that's 3096, is left for my prompt that I can now send to the GPT LLM for doing some intelligent work. So let's say you're doing a one shot, few shot prompting, or you're doing priming, which I'll show, then you are left to deal with 3096 tokens only to send instructions to the GPT LLM. And your answer will be within thousands. So total, if I have 30196 plus 1000, basically, I'll end up with a 4000, 96 tokens. So this is how the maths works. Next confusion to kind of de-jargonize is that OpenAI GPT LLMs are very important, and even an interview question for you it could be, that is, let's say specifically OpenAI, GPT LLM. So are these supervised deep learning or unsupervised deep learning models? Good question, right? So the mandatory read on the white paper is that improving language understanding by generating pre-training. It's basically by Radford et al., where he kind of explains this, right? This is a white paper from OpenAI, by the way. The image that you see on the screen pretty much explains everything in detail. So your answer should be on the left-hand side, as you see, right? I see, that's basically, so the answer is the GPT training process is in two stages, and that's the fundamental. So the stage one is I have an unsupervised pre-training. So the first stage basically learning for a high capacity language model, right? I feed in a large corpus of text. And the unsupervised, this term here technically means that I'm training the transformer model with no labels. In that sense, the GPT model does go through what we call unsupervised pre-training. It's basically, an equation is given there in that white paper. They explain this equation. But this is not the full story. So if you just say that my GPT is an unsupervised pre-training model, that answer would be incorrect. Why? Because at this stage two, the first step is followed by a fine-tuning step, very, very important, where we then take the model, we adapt it to do discriminative tasks with label data. So when it comes to predicting the token in training, right? In case you remember, we covered step by step how a GPT LLM predicts the next best token, right? In one of the earlier slides. The output is then compared to the actual complete input sequence to calculate what we call the loss function. We find the gradients and then do something called a back propagation actually. So in that sense, if you see the second equation, what we call GPT model would be rather self-supervised. So the answer should be to the question is, OpenAI GPT basically introduced what we call a task agnostic LLM. So via two stages, it had stage one, which is unsupervised pre-training, and then you have a discriminative fine-tuning, which takes care of loss calculation, gradient calculation, back propagation calculation, and all of that. In that sense, it's a self-supervised large language model. It is not unsupervised or supervised. That's the technical kind of bit of an explanation. And one more fundamental is what drives innovation. This is very also important. If you're entering into this world, you want to work someday on generative AI models, and build maybe LLMs or fine tune them. So a fundamental question would be like right now, if you open up the news or news feed, it'll be full of different companies, small and large, services or product, OEMs or non, creating LLMs. The fundamental question that you should be asking yourself is what is driving this innovation or what we call this particular, improvement. So the answer is basically four factors drive this. First is, as explained in one of the earlier slides, for those who were there in the call, right? We explained that different variants. You had the encoder decoder, you had the encoder only and decoder only. Majority of the 99% of the right now research is on decoder only. Why? We covered this. The decoder only transformers have seen the most growth owing to least what we call regularization. So the maximum freedom is provided to the weights, resulting in innovative solutions, right? And the birth of a whole range of solutions. So again, a lot of experiments show that decoder-only LLMs trained on an auto-regressive, what we call language modeling, objectively kind of exhibits the strongest, again, not going into detail, zero-shot generalization and all that. So these are driving a lot of innovation, right? People are building decoder-only transformers. Scale, we covered this in the foundation model. Too many parameters if I use, it will be costly and useless. Too less parameters I train an LLM, it will be have very poor accuracy. Nobody will use it. So the balance is to be found with trial and error. So it requires more parameters to capture and define the contextual subtleties, as we will see in the demos. Task generalization, this is very important. This is the essence of generative AI, right? OpenAI, for example, is to provide the most effective solution to potentially optimal number of tasks so that I don't have to again retrain the model on specific requirements. And self-service can include ChatGPT for chatting, creating images, etc. Right? And finally, the last very important point, in fact, this is the practically the most important out of the four, is diffusion. So diffusion is what we are seeing in the industry right now, is the application of generative AI into, let's call it, different application sectors and its generality of use. Let's say you have built the world's best decoder only model. You have scaled it, you have fine tuned it, trained it, you have task generalized it using homogenization properties and so on. But you have built it for such an industry that you don't find any application use case. Then will it be highly adopted? Will it be very innovative? Will you see people researching on top of it, building fine tuned tasks out of it? The answer would be no. So diffusion would play also a vital role. So technically, this domain is a massive area of research right now. And if you're following news or Azure News in particular, you will see a host of announcements around, our events around this. So we want to kind of take all of these which have been built and then eventually build not only industry use cases, but also help build something called self-service assistance, which organizations are asking for, or enable development of what we call assistants. So self-service can include like ChatGPT for chatting, creating images, again, analyzing data, Microsoft Office 365 Copilot, and so on. And development assistants would be like ChatGPT, OpenAI Playground. GitHub Copilot is, fantastically well works. A lot of organizations adopted it for, ease of and automation of development tasks. So this is again a very big area of research, that is the applications of what has been built post task generalization. This I really wanted to kind of touch upon. Moving on to a couple of Microsoft Build 2024 AI announcements. Again, you would be knowing that we this is one of our largest, in fact, the largest developer event that happens annually. And let's quickly take a look at three AI related kind of announcements. So first, Microsoft as a whole, right, is committed to bringing more models from organizations like Mistral, Databricks, Cohere, Meta Llamas, then Co42Js, entity data, which are all coming onto and on being onboarded to Azure AI. The focus here is that Azure should support the broadest set of models from different countries, supporting different languages and eventually for specialized tasks. So if you are a customer or if you are a developer building solution for a specific industry use case, you should definitely find it on our platform. Where do you find it? So these are all available with Microsoft, something called Azure AI Studio. In case you have not heard of it, please do research about it or get some hands-on on top of it. It's basically a SaaS which gives you models as a service, which we are going to see and today a little bit as well, and available to you as a developer SD also if you're building LLM applications. So you should focus on building your use cases quickly and ramp up instead of spending time, money, energy, and resources for setting up these models for use. That's the core agenda here. And secondly, Microsoft was also the first kind of to embrace Hugging Face via Azure AI has now expanded this basically into an expanded partnership over during the Build 2024. This was announced via which you, if you are an SDE or aspire to become an AI, Gen AI, let's call it developer or a Gen AI app developer, there are a lot of career options out there, right? You can now get access to Hugging Face in open source library with the best in class new and latest language models, right? And you can start using them. The second big frontier for research, again, this I really wanted to touch upon, is because if you are looking to build your career, maybe not right now get into the industry and start working, but going to research, let's say. then that you should definitely look at small language models. In fact, at Microsoft, this is also one of my core interest areas. Again, this demands like a 5 hour discussion of its own, because if you want to go into depth, there are a lot of ways in which LLMs can be converted to SLMs. You'll not go into that. But the key takeaway from this slide is just at a high level, you should understand what this is. And that Microsoft's SLM introduces what we call a family of 5 tree models, which is practically leading the SLM revolution today. So the small in SLM, like what exactly is small? Small is the number of parameters that the model has. That these models are typically trained on a large corpus of high quality data, and then they'll learn to predict the next work in the sentence, which this allows you to kind of generate coherent and contextually relevant sentences. And these are very lightweight in nature. And Microsoft offers basically a 3 family of SLM. So these are very perfect balance between capability and cost effectiveness. And the important point to remember is that if you do go back and watch this, keynote of Satya in Build 2024, he announced the addition of 3 new models. We already had Pi3 Mini. This is 3.8 billion, parameter SLM. It already existed. The 3 newly announced were Pi3 Vision. That's a 4.2 billion, parameter multi-modal SLM. Again, this is which produces cutting edge, capabilities across language, text, vision. You have the Pi3 Small, which is 7 billion, Pi3 Medium, 14 billion parameters. These are again SLMs. They're all available as a model as a service, like I mentioned in the previous slide in Azure Studio. So if you are starting out your AI journey today, let's say, or generative AI journey today, in fact, and you're interested in building applications across cloud, you should definitely take a look at, SLMs. And then finally, I mentioned this, it's just not about building the LLMs and SLMs, but, as a customer, you also require the best tools for the job. So we announced in 2024 in Build, Satya announced the general availability of our most comprehensive tool out there. It's basically called Azure AI Studio. You should take a look at it. You can do API model choice, complete AI tool chain. It has all the responsible AI built into it. Over 1,600 models are available to you from different openings at the same place. You should definitely take a look at it. You can build your projects. You can do benchmarking, which is a world of its own. You can, build different apps across different models, do the testing. All the customers that we have right now are starting the journey on Azure AI Studio and then taking it offline, basically once you scale it into, full-time applications. Now, quickly look at what the different use cases. Now, again, I've provided 2 links. Possibly you can take a look at these 2 links. 10 ways generative AI is transforming businesses. It is a blog post which shows 10 practical customers, how they're using stuff, and AI customer stories. It has a lot of AI actual customer stories. At a very high level, I'll try and cover 4 things so that, again, if you are starting to look your journey, in the outside world, you should be aware of these, right? These may come up in your interviews also. Is, can you give me some major use cases in some major industries? So we are seeing basically across 4 industries: medical and healthcare, retail, BFSI, that's financial services, manufacturing. In the health world, we are now basically, the effort is basically how can you assist medical professionals in their medical tasks, right? Allowing them to kind of complete, faster and spend more times, with the patients, in fact. So you can do things like, basically with AI, the gap is becoming closer, right? And smaller. So you can enable them via virtual agents to do things faster, introduction of new professionals, that is the core essence, the use case we are seeing in healthcare systems. So 31% are actually using virtual agents. Retail. Now, in my earlier role, before moving into this role, I was working with Microsoft's largest retail customer globally. And again, they saw a massive expansion of AI. Purely, this is AI assisted shopping experience. End customers, how they can provide better customer service, digital racks, virtual trying. This is like an hour discussion of its own. Like there are so many use cases in retail. If you are someone interested in this, possibly you could deep dive into it, build up one use case, build your LLM model, or fine tune an existing one, build some application and show it to the world, right? You can easily get good customers out of it. So things like behavioral analytics, it's a world of its own, right? Then financial services. So again, this is a world of its own. 32% use natural language text understanding. This is basically focused on to, if you have a mathematical brain, right, improving trading algorithms, making sense of big data, laws and regulation, detecting fraud. Fraud analytics is a world of its own in financial services, right? They are heavily using generative AI. And then finally, manufacturing. I mean, manufacturing, again, 24% use robotics. That's just one angle of it. but then you can enable robots to handle more cognitive tasks, autonomous decisions, and these are all optimized for different use cases, right? Again, there are multiple ways in which manufacturing is using, but one of the fundamental areas that you can look at or research if you want to get into this is already it's been utilized for optimizing processes. How can you further optimize the processes using Gen AI? Basically, improving the what we call bottom line of large manufacturing plants, right? Without taking names, I happened to visit one of our large glass bottlers in the country some years back. I remember they were producing like at one time, one machine produces a few million bottles. The bottles are for jam, for beer, for drinks. So if you reduce 0.1% of their error rate in one of the production line, it impacts like 10 crores, 20 crores, 50 crores, and so on in the final output. So even if you are not revolutionizing the field, if you just impact bottom line, it's enough for these four industries. So wanted to again, kind of mention this. What I'll do is instead of we covered a lot of theory right now, but it's better always to remember, and it's easier to remember if you see, live demos and basically, hands out, and also you do some hands-on. So before we take a look at the demos, just to basically to set the context, right? A few points here. So GPT-3.5, we're gonna see. So 3.5 Turbo and 4 language models. Again, these are optimized for conversational interfaces, right? I meant, and previous models we basically had was simply text in, text out. Basically, you feed in a prompt string and the LLM returned the completion. But 3.5 onwards, right, and GPT-4 onwards, it's important to remember that these are not just message in, message out, but these are mainly meant for conversational interfaces. That's the core difference. So as you will see in the demo when we discuss, right, it's such a articulation, we can prime it to an effort. Then we're going to definitely take a look at GPT-3.5 Turbo OpenAI SDK. If you are looking to move from just the Azure AI Studio into building serious applications or become a Gen AI developer, you need to master this, right, and go deep into this. And then third is, let's say, basically a good career option is you join an enterprise and they say, you know what, we already have 3,000 applications. We can't build everything from scratch, but we need to infuse LLMs, the entire LLM capability right now for 1 hour, whatever you spoke about, into, let's say, our applications. How do you do it? So Microsoft has something called a semantic kernel. It's basically an open source kernel, and you basically infuse the LLM capability into it. Three type of languages exist. You need to either know Python or C# or Java. So I have taken Python for the first one and C# for this. But again, as a recommendation, if you want to get serious and onboard into this, please pick up either of the three languages or possibly two or all three if you can. That's excellent. So I will stop sharing right now. I will, hang on, sorry, also exit my thing and then share Visual Studio. Now, folks, can you see my screen once again? Yes. So
Yes,
I
sir.
have shared my screen. Thanks, man. So quickly, I will explain what this is. So right now you see some, code on the screen. So this is basically running in Visual Studio 2022. This is a Python project. Your first step is basically, let's say I hope the screen is visible. I'll make it a little larger in case it's not. So basically, first you need to import the OS module, to interact with the underlying OS basically. And then you need to basically do a pip install OpenAI to install the OpenAI, Python SDK basically, and then import the Azure OpenAI. Basically, it's a class, it's a library, right? And then what we do is the next step is basically create a client, what we call, let's call it a instance of the Azure OpenAI. Now, three things are required if you're using the Azure OpenAI. Two things are required. Remember, this will become two if you're using just the OpenAI. What is the difference between OpenAI and Azure OpenAI? As I covered, OpenAI is just the bland model. Azure OpenAI is the one hosted on Azure with the enterprise capabilities. So you need the endpoint. So for example, for the Azure OpenAI Studio, I have already created an endpoint by hosting the model. And this is the OpenAI basically endpoint that I have to the LLM to talk to it. Now, a very important point, you also need to create a key, but do not keep the key in the code. It's a bad practice. For demo purposes, again, I'm basically using an environment variable so that it's not on the screen. But guidance here is please use either Azure Key Vault or preferably there is something called a default Azure credential. It should be like this class, which provides a basically default token credential in the auth flow. Please use that. And also you need to give the key, the API version. So I give the endpoint, I give the environment variable for the API key and the version. So basically, let's say for the chat completions here, basically, I need to do. So you create a chat, basically create completions class. So this is the client.chat.completion.create. So the message parameter take an array of, basically, if you see, this is an array of message objects with a conversation organized by role. This is very important. When you use Python APIs, basically technically it's a list of dictionaries, right? And the output is stored in form of a response object. And you will see that there are three different type of roles. You have system, user, and later also you will see an assistant. So what are these? The system is basically the system message. It's beginning of the array, right? So this is basically I'm passing instructions to the LLM, saying that give me a brief description of the assistant, personality traits. I can use it for priming and all of that. And after the system role, you can include a series of messages between the user and the assistant. So let's say first, and these are what we call the hyperparameters. Again, these are the temperature, max token, top frequency, presence, penalty. So let's understand first what exactly is happening. So what is the message here? I'm saying, that, you're an AI assistant. If somebody asks you a question, if you don't know the answer, just say so. So the basically question I'm asking is, hey, can you help me with the employee ID of a Subhashish, of an employee who works at Microsoft? So let me close this and let me start this. So I hope it's on the screen. So you have a pop-up window which opens up. So I hope the pop-up window is shown on the screen. Can someone confirm it's visible?
Yeah.
Yeah, thank you. So I'll make the size a little larger, man, because this is the core bit of it that you need to understand. So this that comes up basically is basically the output. And I have kind of extracted the final output. But before that, I wanted to capture the token usage. So this is all in English that I explained in one of the earlier slides. This is what exactly the 59 prompt tokens, as you can see, which is kind of being taken from this particular task. And 47 completion tokens were used for this particular task. Total is what? You add both the 206. This is very important to know my token usage. But see, it gives you perfect answer. Says, I'm sorry, man, I'm an assistant. I don't have access to personal or specific employee information. It's best to contact Microsoft if you really want to know the employee ID of Subhashish. That is perfect. Now, if I kind of close this and let's say we move on to the next one, I set up. Now here I'm giving the same question, but I'm asking with Sid Barrett. So now let's understand how this works. So again, any fan of psychedelic rock or classic rock who have heard of Pink Floyd, Sid Barrett was a legendary figure of, the founding member of the group. So as you see, absolutely correctly, it mentions, it pulls from its dictionary, and, gives you the name of one of the immortal names in the progressive rock. So as you see, public information, it can definitely search for, but private information, it can't. So you need to either ground it with an LLM or we'll get into some of the details, right? So this is an example of what we call one-shot engineering. You will do this when you work on complex projects. So here, for example, I'm telling him that you are an assistant. Please answer in a consistent style. What does that mean? So the user feeds in, what, for example, teach me about patience. Now, there are multiple ways you can teach, patience. But here, what exactly is given is role is the content. I'm providing also the river that carves the deepest valley, flows from a modest spring. The grandest symphony originates from a single note. So it's a beautiful flowery English language. So I want the LLM to answer not just in blatant, bland English, but be consistent to the style of what I'm feeding in. This is very important, correct? And I want him to teach me about gratitude. Now let's really see this, how this works. So I set this up as a start. And whether the LLM can actually do it or not is the question. And ideally, how you should test an LLM is by running it a couple of times. Uh, you know, so it says gratitude is the art of recognizing, appreciating big and small. The grace lies together. Practicing gratitude cultivates a sense of author, helps us to focus what we have. It reminds us to cherish, fostering a greater sense of joy. So it's the art of. So let's say. So this is pretty good actually. But let's say I want to run this once again, correct? And let's see, is the answer different or is the answer the same? You know, ideally it should be different because it's every time it's generated fresh, right, for you. See, this is a completely different answer we receive in our lives. The mindfulness, the positive aspects around the big or small, like a gentle breeze that brushes against our face. My God, gratitude in the sense of warmth and contentment. It's perfect. So this is a proof that it's not been pulled from a database, but rather, again, if you remember the slide, token by token generation, the best probability of a given token in a given context sequence within that contextually relevant, sequence is what is the next, token is generated. So it's a token by token, sequence to sequence model generation, happening in real time. This is, let's say, look at this. This is basically, what we call a few shot prompt engineering. I want it to only answer related to taxes, but taxes not in India, but in the UK. But how would the model know? I'm not mentioning it anywhere, right? So when I say, when I give my taxes by in 2023 by April 18th, I'm feeding in the answer. And I give the IRS gov. So this is not UK, I mentioned wrong. It's in US, right? The IRS. And how do I check? You can check the status of the tax refund. Can you provide me with some information on the donated property? Now, this is where it gets complicated because tax information on donated property is different from in India, in UK, in US, in every country is different. So let's see what the model says, right? In real time. So let's play this out. First of all, can it detect? Second, if it detects, can it pull? And number three, how does it direct you? So a lot of info came up. Let's see what it says. Certainly, when you donate property to qualified, did this dictating. So as recognized by the IRS. So see, it has correctly detected that you were trying to understand from the US, not UK, not India, not Africa, not other countries. And also see, it gives you dollar values and it gives you contextual information. Again, you need to kind of check it out and give the correct one. Basically, so this is how, kind of you can prime the effort also, right? For example. And one last question I want to show is to you is specifically the conversational bit of it. Kind of if, so, and what's the drawback? And also if you do a conversation, what's the kind of effort the model puts and what kind it kind of gives you? Like, for example, how are you today? So it asks me, right? So let's start the conversation, right? I don't have feelings, but I'm here. So how can I help you today? Do you know where, sorry, is UPES CSA situated? And we'll make the conversation much more complex. So see, first of all, it detected it's located in Dehradun, India. Perfect. Does it have a course in, or does it allow to study computer science? Now, please understand this. I am not saying it means contextually means or UPS, CSA I'm talking about. So let's see whether the model can detect it or not. Can it contextually make it relevant or does it give you anything? See, it does. It says, yes, UPS CSA offers where I have not provided it. So the contextual history is pulled it into the conversation. Does it offer, let's make it even more complicated, sociology? Now I really don't know, but I'm actually finding out, right? So it says no, UPSC does not offer in sociology, correct? It bring other engineering, so if there are students here on the call, they can confirm it's correct or not, right? Does, what about Oxford? See, here I'm making it even more complex. I'm not even giving the subject name, not even mentioning the context that I'm trying to ask whether this university has sociology or not. Let's see. I really don't know what the answer will be. Offers a wide, see, it gives you perfect. It first tells you about Oxford, it tells you that it offers, also tells you that sociology is one of the subjects. This is perfect, right? I mean, and let's say, basically, I'll make it much more complex, which let's say I'm trying to make it fail. I want to eat samosa. Does UPS CSA cafeteria offer samosas? Now, this I really don't know, but let's say I'm visiting, I want to find out. So what does the LLM say? I don't have real-time information about specific cafeteria or campus cafeteria offers after including samosas. I recommend checking with the UPSCSA. This is perfect, right? If it does not have the information, but you can ground it or do some form of sharing, right? It can basically give you that information. So this I really wanted to show you that you can have a conversation like this, take it forward. And one bit of it before I kind of hand it over for quiz is I will close this solution and open up this semantic kernel one. This is basically the open AI. I mean, for Microsoft has created this particular, open source SDK. So you basically have the Microsoft.semantic kernel. It's a meta package. And again, do not embed. You just use the API key, which I mentioned. And basically you create a builder in which you create an instance using Azure OpenAI chat completion. Again, only three things are required. You give the deployment name and the endpoint and the API key, which is hidden in the environment variable. Now I wanted to show you something here quickly and then, end. So let's say if I run this, let's say, so I've asked a couple of questions. What color is the sky? I've asked the question, where is, again, the same thing. This is in C# you're seeing. The earlier one was basically in, what do you call it? Python. So see, first here, it gives you during the day, the sky appears to be blue. This is perfect. UPSC is based in Dehradun, Uttarakhand, also perfect. What are the few things a boy can do if his girlfriend, I think, is angry at given? Uh, wow, it gives you a lot of points to you to take a look at. And now basically I have basically an invoke prompt testing. That means I want to take a prompt and have a conversation with AI. Now here I want to show something very important, which you need to remember if you're tomorrow, building LLM applications like these for enterprises is, let's say, hey, how are you doing today? So this is 3.5 answering back at me. He says, as an AI, I don't have feelings. How can I assist you today? Uh, my name is Subhashish. God, I'm typing my name wrong. Okay, so let's say what it says. Hello, Subhashish, how can I assist you today? Do you know my name? So in the previous one, I had basically given my name. Right now, I'm trying to see whether it can tell me. So what does it say? Say I apologize, but as an AI, I don't have access to personal information unless it has been shared with me during basically the conversation. What does this prove? So basically, the LLM failed here, right? Because I did pass my name, but it does not know the name in the next prompt itself. So this basically proves that the LLM by default, when you use it, right, in any language or any type of application you're using, is basically what we call, inherently stateless. This is a very important point. Unless you explicitly program them. Now, there are multiple ways you can tackle because in an enterprise application, right, you need to be able to remember things from history, right? So there are multiple ways you can do that. So if I kind of close this, and now basically I go and do do this much. I don't need this. I delete this bit of it. So let's see what now we are doing here. So basically I've created the kernel. I've used a kernel builder. Again, this remains the same. I'm building basically an instance. This is basically creating an instance. The conversation. What to type that in? So basically what you have here now is, so there are multiple, first of all, let's understand there are multiple ways to do this, right? So first is you can either, like I was doing in one of the Python programs, you can render in a prompt yourself, or you can rely on the, SDK to do it for us. That means you can rely on underlying clients, right? You Azure OpenAI or OpenAI or whatever, any some other chat service if you're plugged in. So these are multiple ways to handle it, right? Or you can directly ground it with another data, or you upload a particular file into it and get the past history loaded into it. So this is a good actually interview question if you are, let's say, interviewing for a role, that how do you solve this kind of a problem, right? So the correct answer is there are multiple ways to do it. The most like approached way would be to kind of getting a chat service up and running. So for example, here basically I have a chat service variable. I'm doing a kernel.get required service, and I have a iChat completion service. So this basically, interface is creating a new chat, which is essentially just a list of all the messages kind of added to it. And they're not using, issuing any requests and printing on messages, but we are based storing into the chat history. So if you look at the code, right, there are two important things here. The first one, again, I mentioned the interface. This is the interface for the chat completion services. And the second, also very important, is so I do a response, await a chat service dot get chat response or message content async. This is also very important. This is basically a method which basically gets multiple chat content choices for the prompt and the settings. And I'm basically, giving the chat history and feeding it into the prompt. Why is it async? So that the performance is good. Basically, it's asynchronous, call to the multiple chat content choices or items in that array. So basically, it then recalls the history, and then the chat dot, gives you the response, into the history. So let's see this, if this works or not, if it passes the test or not. That's the main point. So let's say question. Hey, how are you doing? Even if you spell it wrong, it should work. So let's say today, the Y you say, it should work actually. So I'm an AI language models. I want to experiment, but thanks for asking. How can I assist you today? Do you know that my name is Subashi? Yeah, let's type this in. I now know your name is Subhashish. How can I assist you further, Subhashish? What is the color? So let's now deflect it to some completely other conversation, right? The agenda is to remember not immediately, but from a set of array objects, you should be able to pull it, right? So what is the color of the sky? So let's have a normal first conversation. The color of the sky depends on blue, ding, 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 ding. Okay. Where is UPS CSA based? Do you know? Um, Research and Gambling Center UPS. Okay. Can I take flights? So let's say now it has had different topics per conversation, one on color, one on university, one on travel. Do you know my name? Now this is the actual test. Yes, your name is Subhashish. See, correct. It absolutely pulls from the history actually. So even if it had other conversations, but the contextual and the history from the get chat message context async method, it's able to pull from that iChat completion service. So that's the core agenda. So this is how, and this is basically just one part of it, but then you can do prompt engineering here. That would be even better. So let's say I now take this and say I want to fine tune this entire thing specifically for one let's say university or one medical use case or from a particular health center. You basically would upload the information into this and then do kind of grounding the data into it and basically kind of outputting the effort, right? That's the correct way of doing it. And one last thing I also wanted to quickly show, even on here you can show it. Hey, how are you today? This is also I wanted to kind of explain so that everybody is aware of it. This is fine. So let's say when did uh, Narendra Modi win? What is that called? Civilian award. I have forgotten the name anyway. Award in Russia. Now let's see, can it really detect? Uh, Correct. So this is absolutely wrong, right? He got nominated just like 2, 3 weeks back or like few days back. So this is in LLM terminology, what we call hallucination, right? So you have to always safeguard your LLM against hallucination. Why did it give the answer wrong? Because the secret is hidden always in the model you're using. So GPT-3.5 Turbo. So GPT-3.5 Turbo, the date of training cutoff is I think September 2021. So it will have all the info by default before that. Post that it will not. If post that you want to train it, then you have to either use. So what's your ways here? Let's say you're given this problem to solve. Either you need to kind of use the more recent model, or you need to kind of ground it, feeding in your own data, or you need to do prompt engineering. Multiple ways you can do. Fine tuning model not required really. So this kind of brings me an end to this conversation, and to whatever demos I wanted to show. I will stop sharing my screen, and I think I need to hand it over to Yash for the quiz bit of it. So Yash, over to you.
Yeah. Thank you so much, sir, for this insightful session on generative AI, and we truly appreciate your time and expertise. So moving forward, let me share my screen. We Now it's time for an exciting quiz where you participants have some chances to win some exciting goodies. So like Give me just a minute because there is some problem. Uh, Guys, I think I need to wait because there's some error. Just a minute. I need a minute, but uh, can anyone confirm if you can see my screen?
Yeah, we can see Yash.
Yeah. So, participants can start joining by using this QR code and this code, quiz code. Yeah, I pasted the URL. Also, the code in the chat. You can join by using this URL and the code. I pasted in the chat. The people have started joining. Please join as soon as possible so we can finish the quiz. We will be starting at 1:24, so please join before that. So we are starting with our first question. The question will be in 2, 3, 2, 1. And here's the question. Attention is all you need. The research paper from Google that introduced the original transformation model and revolutionized Gen AI was published in which year? The options are 2016, 2017, 2019, and 2021. Times is up. Okay. So the leaderboard will be displayed after the quiz ends. Okay. Moving to our next question. Which is the latest general availability multi-model from Azure OpenAI service. This LLM allows you to do text, video, and Audio processing. Options are Dell A3 and GPT-4 Turbo, GPT-4o, and GPT-4 Turbo with Vision. Okay, so we can go to the third question. I want to design a model which should deliver great performance while remaining lightweight enough to run on Apple iPhones. As a generative AI program manager, which type of model should I look to design for the use case? Options are foundation models, LLM, and small language model, SLM, and large multimodal, LLM. Moving forward to our fourth question. For a LLM, what represents the size of LLM's available memory area that is preload with the question, and also where answer must be generated following that output. Options are token, model ID, context window, and max request. Moving on forward to our fifth question. I am tasked with improving the performance and relevance of an LLM. I pull in relevant contextual information from an external database, and the LLM uses this added context to produce a more knowledgeable response. What is this called? The options are in front of you. So we have reached to our last question. In a transformation decoder only block, which are the two key concept design that make it more efficient, able to generate new stuff compared to the original encoder decoder model or encoder only block model? So we have ended our quiz. The leaderboard is in front of you. Sujal is on the top, and Abhishek Tarafdar is our first runner-up, and Sanoj is our second runner-up. So congratulations to you guys, and you can we will be mailing you for to get your information, and we'll be sending you the goodies. Okay, so moving forward, let me share the PPT. Okay, we have ended with our quiz. So all of you can follow our Instagram or our social media handles so you can get more updates about our upcoming events or any activities that we will do. And again, thank you everyone and our speaker Shubhashi sir for delivering this insightful session on generative AI. And the winners will be receiving a mail so to send our details so they can receive their goodies on time.
Thank you, Yash. And Yash, I will send you the PDF version of this deck to you by mail.
Sure, sir. Sure, sir.
And also a GitHub code link. I will upload all the code to a GitHub repo. I'll give that link also. Do share it with everyone. Thanks then.
Yeah, I will share these three details, like including the recording of all this, and we will be mailing them these things.
Absolutely. Thanks. And thank you, everyone. Thanks. Thanks, team.
Thank you. Yeah.